Okie dokie, my little pony, let's get beginning. So I just forgot to hit record on the first half of the 3 o'clock section. Sorry if you are using that to review. I would like to do different problems for this than I did in the 3 o'clock, and that way people can use the half that I did record if you watch the YouTube videos to assist yourself. I'll emphasize again that a very important and useful thing to do is I posted a practice test that's very similar to the real test. It's last year's midterm one. Uh, do that. Do that with your equation sheet that you're using for the actual test. Get a feeling for what don't you know at the level that I'm asking, and then go study that. I do want to emphasize, because I had a student mention this in my 3 o'clock class. She took the practice midterm with Google. If you use Google, you're not going to find out what you're going to get. You're not going to find out what you know. I'm not saying that you can't look up answers afterwards, can't get hints for how to do something afterwards, but do that after you take it and grade yourself and find out what you know and don't know. If you take a practice test using the interwebs, you're not going to know how you're going to do when you don't use the internet on the actual test. And if you use the internet on the actual test, it gets ripped up and you get a 0, by the way. Yeah. If you the back when I was in excited about music, what's the phrase in musicians? If you practice as if it's a performance, your performance will be just like a practice. I think that applies to sports and physics and music. So I encourage you, do examples and don't use the internet with them until after you've tried them, made your good faith attempt, put down your answer, and figured out, are you right or are you wrong? Then you can see, all right, well, how can I do this? Also beware, some places on the internet are wrongo, wrongo, wrongo. I do not guarantee, or do things differently enough that if you learn to do it that way, if you learn to do it that way without fully grasping the differences between my methods and their methods, you're going to answer my questions wrong. So watch out. I have not checked the entire internet. I cannot tell you which websites are correct and incorrect. So just let me say beware. Okay. Questions about how to study. Yeah. Is it question 6? I'm going to hit that in 2 seconds. Other questions not about midterm 6. General procedural questions. Does anyone want to ask what you're allowed to have on the midterm equation sheet? Whether I'll give you stuff, whether the exam is in this room or anything like that? Yeah? You are allowed calculators. Always on my tests, both midterms and the final. Anything that fits on a half sheet front and back, or for that matter, same area, the whole sheet, just the front, whatever. Yeah, yeah. Yep, yep, half page front and back. Or cut it in half. Yeah. Yep, exams in this room, in this period, next class. Yeah, no, I have not yet. I still do intend to. If you cannot make it, worst case, I'll hand grade the freaking, I hate hand grading, but worst case, I will do it. But I'd really prefer to minimize that. So I will try to get some. Please do your darndest to get them yourself. And there is a fallback. It's not like I won't let you take the test if both of us don't have it.
But we're using the moment we get in, once class starts, we have the entire time period.
I mean, I'll pass out the tests. Yeah, that'll take a minute, but yes, we're using the entire period. But if everybody finishes before 75 minutes, before the class period ends, I'll tell you all the answers. So you can walk out of here knowing what you got. obviously after y'all have turned in the scantrons. But I might, depending on whether my wife says so or no, stay even after class. It's hard for my wife when I stay after. But if she says so, I'll stick around and tell you even after the period. Yeah, make sense? You know what I'm talking about? Okay. Other questions? Other procedural questions before we get into content? Okay. Yeah, please. 20. 20 questions. We're going to play 20 questions. You will not be provided equation sheets. You are responsible for making it. No. Bring your own scratch paper. I format my tests. It's not like I condensed the practice test from what I normally do. I usually put 3 to 5 questions on a page. There usually is enough white space for most students. You are welcome to bring blank paper as well. Yep. Sure, yeah, that works. But as I said, very few students that I see at the end of the class are throwing away additional paper as well. I put a fair amount of blank space. Yeah. Anything you want. Anything you want. You could download it from the interwebs if you want, but be careful. All right, content. I would like to start by addressing the midterm question 6, the practice midterm question 6. The best answer is C. I goofed. I'm such a big goof. I'm such a silly. I said that it's moving with a non-constant acceleration. Correct answer is moving with a the zero acceleration. If the velocities are not changing, delta V is 0, A is 0. I'm sorry. Okay. That said, I would like to start by doing some force problems, see where all y'all are at. And if the force is good, if you have the force, if you can use the force, Luke, then we'll go back to kinematics problems. As I said at the beginning, though, I did kinematics all for the 3 o'clock period. And if you're using both resources, the videos for both, then there you go. I will say, don't get the wrong impression. If suppose you guys suck at force on average, and we need to spend all period on it. Force is about a quarter of the midterm. A little bit more than a quarter of the midterm. So don't think that it's just because we're spending a lot of time on it. We'll spend time on it because it's new, not because it's half the test. Yeah? Question? Kinematics. We spent 5 lectures on kinematics and 2 on force. So 5/7 of the questions are on kinematics and 2/7 are on force. Okay, but y'all are brand new to force, so I think this might be useful. Let's do the Google form so I can check you and find out if you need this. We're gonna work on what you need. Google question A. What is the unit for force? How do we measure force? What is the SI unit for force? The unit, by the way, not the symbol. For instance, the unit for distance is meters, not x. X is a symbol, unit is meters. Again, for force, when we talk about force, not velocity. Okay. I'm curious here. Let me check something here briefly. I'll tell you the correct answer in a second. Question B, what is the SI unit for weight? Question B, what is the SI unit for weight? SI, the scientific unit. I did not make a big impression on this sucker. Okay, so question A, most of y'all got correct. The SI unit for force is the Newton. Good. Those who answered pounds, kick. Pounds are barbarian units. I was raised as a barbarian, but anyway, silliness. Okay, part B, weight is a force in physics. So if we measure all forces in newtons, weight is measured in newtons. What is the conversion factor between newtons and kilograms? If I exert a 50 Newton force on something, how many kilograms have I exerted on it? Depends on which planet I am, depends on how hard I push, depends on what? Hey, let me ask you this. If I'm moving at 5 miles an hour, what time is it? What time is it if I'm moving at 5 miles an hour? I've got $50 in my bank account. Happy estimate. Got $50 in my bank account. How old am I? No idea. Mass and force are different units. Can you convert dollars to hours? I mean, there's a connection there. If you're at work, you make an hourly rate, you could talk about the dollars per hour that you earn, but I do want to emphasize, weight is not mass. Mass, how much of you there is. Weight, how hard you are pulled. On Earth, each kilogram of matter is pulled by 9.8 newtons of force gravitationally. Does that mean that there's a 1 to 10 conversion factor? No. Go to the moon. Well, not before the test. After the test, go to the moon, and you will find that 1 kilogram only weighs 1.6 newtons. Go to Mars, 3 point something newtons, 3.2 newtons. It's not an equality. It's not a conversion. It's not measuring the same thing. The ratio of weight to mass tells you something about the gravitational field you're in. The ratio tells you about how big and how massive the planet you're on is. But they're different kinds of things. Again, it's like if you try to convert if you try to convert distance into seconds, maybe that's true. There is a relationship if you're moving at a velocity at a steady speed, but the distance in seconds measure different things. Meters and seconds basically measure different things. So watch out for that. If I ask you for the conversion factor between meters, the kilograms and newtons, the correct answer is none of the above. They are measuring different things. Now, if I ask you for what is the weight, here's a Google form question. Google form C, what is the weight of 1 kilogram on Earth? Chop chop, quick money. What is the weight of 1 kilogram on Earth? Come on, chop chop. Give it your best shot. Shh, no spoilers. 10 seconds. Okay, so let me emphasize again. What is weight? What's the meaning of weight? Weight is a force. Okay, what is the meaning of kilograms? What do kilograms measure? Let me refer to my previous line that I just wrote on the board. 1 kilogram is pulled by 9.8 newtons gravitationally. The force of gravity is 9.8 newtons when the mass is 1 kilogram. We can express this with an equation that I wrote on the board. The weight vector is negative mass times field strength. Remember this? Remember this from last time? Weight equals negative mg. The strength is your kilograms times 9.8, and the direction is downward. Okay. So, is there a conversion factor? No. Is there a relationship on a given gravitational field? Yeah, but they are not the same thing. What the hell? Here's another fast one. D, what's the SI unit of mass? When do you know that there's a mass? Question first. Well, if I'm saying the direction, if I'm specifying weight, force, just talk about it as an amount, I wouldn't tell the direction. I would say it's 9.8 newtons. If you are asked for the force vector, the weight vector, magnitude and direction, the negative sign is important. But yes, on Earth, in this gravitational field, there is a downward force of 10-ish newtons per kilogram. Yes. 9.8, 10, same diff. The best answer, the closest answer there is 10. You're allowed to round, by the way. I would never give you where the different answers are 9.8 versus 10. Questions? Okay, let's see how you all did on D. The SI unit per mass. Oh, procedural thing that really rustled my jimmies. In the 3 o'clock class, I was very concerned because the response rate was very, very low. A whole bunch of people were unable to answer a bunch of the simplest questions. And then I realized that was because they freaking were submitting new form. In the Google form, what do you do after you hit submit response? Edit response, not submit new form. That makes it look like there are 50 people who don't know anything in here, okay? It's okay if you don't know anything, by the way, but if I see that half the class doesn't know anything, I'm going to teach very differently. Okay, the correct answer, the SI unit, by the way, the correct answer for this, the SI unit for mass is kilograms. Kilograms is M. M is kilograms. Not grams, by the way. The kilo is the base unit in SI. Okay. Okay. I'm okay with this. That's weight, that's mass. Go into deep space. Google question E. Go into deep space. What changes? Mass, weight, neither, both. Go into deep space, far from any planet. What changes? Does mass change? Does weight change? Does neither? Does both? Correct answers are weight, mass, both, or neither. Go into deep space in a rocket, far from any planet. Does your weight change? Does your mass change? Do both change? Does neither change? Do neither change? All right, so mostly good. If you throw up on the ride, maybe there's less of you. Your mass might change if the amount of you changes by vomiting. Let's assume that you don't lose bits of you. Mass measures how much of you there is. Mass does not change depending on where you are. However, if G changes, the gravitational field strength changes, then weight changes. Weight equals mass times field. If you go to a different place with different amounts of gravity, if G changes, then weight changes. The correct answer is weight only. Mass does not change if you do not change. Weight changes if the gravitational field changes. Okay, I'm all right with that. Let me give another problem, a different kind of problem. Uh, mm, the 1 Newton apple. What am I telling you, by the way? A 1 Newton apple. What am I intrinsically telling you? The what? What about it? If I'm telling you I've got a 1 Newton apple. It's the weight. It's the weight. I'm telling you, you've got a 1 Newton apple. A 1 Newton apple is sitting on a branch. Google question. Show me what you know. Google question F is what is the net force on the apple? Again, what is the net force of a 1 Newton apple sitting on a branch? Maybe it's KISSING, maybe it's not. I don't know. Okay, there we go. Ooh. Last one, 90% were correct. Here, like 10% of y'all were right. Yeah. I've got a 1 Newton apple sitting on a branch. It's just sitting there. What's the net force on it? What is the net force, by the way? And there is absolutely enough information to solve this problem. Okay, time's up. What's the acceleration of an apple sitting on a tree? What's the net force on the apple sitting in a tree by Newton's second law? 0. If you're not accelerating it, there cannot be a total force on you. Remember the law. Let me lay down the law again. Hmm. If your acceleration is 0, bam, there cannot be unbalanced force on you. The branch had better darn well be holding you up with a force equal to your weight, or the apple in this case. Google form, whatever. Google form G is the apple falls. What's the net force on the apple? Again, the question is, I've got a 1 Newton apple. It was sitting on a branch. Then the tree drops it. What is its net force in free fall? This is what we're going to work on for the next little bit. Again, about 10% of you are getting it right. Let me lead you to an understanding, a deeper understanding, hopefully. Google question H. Think about this. By the way, do you guys, uh, maybe this is not clear by the way I do things. When I ask Google question after Google question after Google question, very often what I am doing is leading you through how to solve it. Sometimes I am testing whether you understand something. On average, the class, you is the class, the entire class, how many of you understand something. But then once I drill down and find where the misconception is, I am asking a series of questions. This is called Socratic learning. I'm asking questions designed to guide you to the correct answer. I don't believe in talking at people and just telling you answers to memorize. I think that physics is too hard to tell people physics and have them just, oh, it all makes sense. I think you have to do physics. That's why I'm always having you do things. But if you don't realize that I'm trying to lead you through how and why, then maybe this whole thing seems pointless. It is not. Trust me. Trust the process and look for the connections between my questions. So right now, I'm telling you that 90% of y'all are missing both of these questions. Let me guide you to a deeper understanding of force. First, are you guys comfortable for an apple sitting on the tree has no acceleration, therefore net force has to be zero? Okay, now we're going to drop the apple. I've got a 1 Newton apple falling through the air. Um, Here is how I think about this. Here's how I guide myself to the right answer. H, what force or forces act on the apple? Write it down. Put the Google form. What force or forces are acting on the apple? Just name it. You don't have to give a number. Name all the forces acting on the apple as it falls. Now, Google question I have introduced a different name for gravity force. Do you know the other name? Google form I. Do you know the name that I have consistently been calling gravity force? Google form I. Tell me what is the force of gravity that I have been talking about. It's measured in newtons. It is a force that gravity exerts. What is the name of this force? That I have steadily been referring to? Okay, this is again not being picked up. Question J, I want you to distinguish J. Write a very short sentence, please, as short as you can so I can quickly grade 80, 90 responses. Distinguish between, what is the difference between gravity and weight? Google form J, what is the difference between the terms gravity and weight? Force of gravity and weight force. Okay. Mm, 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 mm. One correct answer. Two correct answers. Three, four. There is no difference. When I say weight force, what I'm talking about is how hard the earth pulls on you. That is the force of gravity. That's what I mean when I say weight in this class, uniformly, always and forever. Weight force is gravity force, is the force that the planet exerts down on you. K, what is the weight of the apple? Can you solve for the weight of the apple? Do you know the weight of the apple? What did I tell you the weight of the apple is? Put it in K. Let me see who's listening. With units, please. Lots of people listening. See if everyone's listening. I will emphasize I'm asking for the weight of the apple. I just emphasize that weight and gravity are the same thing. Weight and gravity are force. So what is the force of gravity on this apple? What is the weight of this apple? How do we measure forces? Hint, hint, hint. Turn to your neighbor and discuss, what did I say in the very beginning of the problem? A blank apple. What does it mean when I say a 1 Newton apple? How much does a 1 Newton apple weigh? No. 1. 1 Newton is the weight. That's what I mean when I say weight. The force on the apple due to the planet is 1 Newton of force. That is weight. Weight is mg. What's the mass of the apple? Put this in Google Form L. What's the mass of the apple? Use the formula, Luke. You may assume that I am on Earth. I will emphasize again that weight is a force, and weight and mass are different things. If you tell me newtons, go directly to jail and do not pass go. I will absolutely go slower. Please slow me down by asking a question in the Google form. You guys can ask questions in the Google form. If you get stuck, if you get lost, if you want me to repeat something, if you are shy about raising your hand or shouting out, you can ask me questions in there. By the way, I'm also never offended if you raise your hand. For instance, question.
How can you say that the weight of the apple is 1? Because
With exactly those words. I define weight force as the force of gravity on an object. If I say an apple is 1 Newton, 1 Newton is measuring what quantity of the apple?
weight.
Yeah, yeah.
So weight is mg.
Weight is mg.
If we keep the mass aside, he will on Earth will be 9.8.
Sure.
9.8 into whatever the mass of the apple will be the force or the weight.
That's correct. 100%.
If the force or the weight is 1 Newton, then the mass will be 1 divided by 9.8.
100%. Correct. Good. You got it. It's clicking. Okay, so the correct answer is about 0.1 kilos. Let's use the formula here. If we've got the weight force, I got to talk magnitude, screw the minus sign for a second, is mass times gravitational field. We have said that the weight force of the apple is 1 Newton. Screw 9.8. You can plug it in your calculator if you wish. I don't mental math that way. Units? Kilograms. Okay, so the mass of the apple is 1/10 of a kilo. You have previously told me that gravity is the only force acting on the apple. Well, most of you told me that gravity is the force acting on the apple as it freely falls to the ground. How do I word this to lead if you confuzzled about this? Gravity is the only force acting on the apple. Gravity is the only force acting on, and furthermore, I have hopefully led you to understand that gravity is weight force is 1 Newton. Tell me, if you can, how might I go from what I just said to finding the net force on the apple? I have told you that gravity is the only force. I have told you that gravity is the same thing as weight. The weight of the apple is a Newton. How could I find the net force? Give me question M. What is the net force if I tell you that the only force is weight? You do the rest. Google question M. I'm wondering, think about the fact that there is one force on the apple, its weight, 1 Newton. How could you discover the net force on the apple? I am asking for a strategy to find net force on the apple. If you know that the apple is in free fall, the only force on it is its weight. Kilograms are not a measure of force. Kilograms do not measure net force, by the way. What Scantron do we use for the exam? The pink half sheet. Okay, time's up. What does net mean? Tell me, it's a question out here. What is net? Total. Net means total. It has nothing to do with fishermen. Okay? The net force means the total force. The only force on you is your weight. The only force on you is your weight. How could I find the total force? If I tell you that the only force on you is your weight, and I want to know the total force, it is your weight. Total means add everything together. If there's only one thing, the total is that force. Again, if you're in free fall, the only force acting on you is your weight. That's how we define free fall. When we're talking about net force, we are talking about the sum vector, sum of all forces acting on you. And if you know that your weight force is the only force acting on you, then your weight force is your net force. Question me. Question. For what? 1/10 of a Newton is not correct. 1/10 of a kilogram is the mass. Gravity is weight. Weight is gravity, same thing. The net force is equal to the weight is 1 Newton. 1. 1 Newton. 1 and only 1. Because I told you at the very beginning, the first words I told you were a 1 Newton apple, and we decided that that means, or I told you, that means the weight of the apple is 1 Newton. The planet pulls down with 1 Newton of force. If the only force on you is 1 Newton, then your net force is 1 Newton. That's what net means. Question? Yes, same thing. Anyone? Free fall what? Acceleration. 9.8 tells you how rapidly something changes its velocity. 9.8 tells you how hard 1 kilogram is pulled. 9.8 does not tell you a force necessarily. Okay, so let me put this up on the board because saying words sometimes when I'm saying math is bad. In free fall, you accelerate downward at a rate equal to g. You accelerate downward with a changing velocity and the rate of change is g. I should put a vector sign to be correct there. I can say that weight force is related to gravitational field by the formula mg. I could say this is always true. G might be changing. G might not be 9.8, but whatever it is, your local gravitational field times your mass tells you the magnitude of the weight force, and the direction is down. Okay, so let's follow this up. The weight of an apple, what letter am I specifying? Weight of an apple is which letter here? Weight is W. Okay, so an apple which weighs 1 Newton is getting pulled down by a certain strength. How fast does that accelerate if I freely drop it? It accelerates downward at 9.8 meters per second squared. Okay, this and this are different quantities. This tells how fast the velocity changes. This tells how hard the object is pulled. What relates force and acceleration? If you are freely falling, I just told you that your net force is your weight force. What equation relates acceleration for God's sake, acceleration and net force? Newton's second law. Okay, and I can plug in if the net force is the weight, if you are freely falling, acceleration equals, what's the weight formula? Mass times field. And what do I discover? Multiply mass times field and then divide by mass. What do you get? Pew, pew. The weight formula, the idea of mass, Newton's second law, acceleration and free fall, they're all related. This could be confusing at first, but if you think of what does acceleration tell me? How fast changes. Acceleration is kinematics. Lets me find where I am and how that changes. What does force tell me? Force tells me how hard I am pushed or pulled. What does F equals ma tell me? Tells me how hard I have to push or pull something to speed it up at a given rate. What does weight tell me? It tells me how hard gravity pulls on something. If you distinguish and assign meanings to these things, I swear it's all a couple of thoughts connecting. It's a web of knowledge. Now keep asking me questions until this clicks, please. Please. The vector of weight, yep. It depends on if I'm talking magnitude or magnitude and direction. If I'm talking about a 1 Newton apple, which direction does that 1 Newton point? So I maybe should say the apple whose weight vector is -1 Newton. Oh, that's a mouthful. I shortened that to saying the apple has weight 1 Newton, and you have to understand I'm talking about the magnitude of it. Just like sometimes I say I'm falling at 20 meters per second. Which direction is my velocity? Maybe I should say my velocity as I fall is -20 meters per second, but sometimes it's convenient to not to say all those words. If you're falling downward, velocity is negative. You'd plug in, if you have an equation, v is -20. But if you're speaking, sometimes separating it out into falling means downward, 20 meters per second is the magnitude. Yeah, see the verbal distinction? Saw another hand over here. Yeah. Sure. Let me follow this up and ask, the apple hits the ground. The ground slows it down. What is its weight as it sits on the ground? Google form N, tell me the weight of the apple as it is sitting on the ground after it falls and the ground stops it. What is the weight of the apple as it sits on the ground? Please check your classmates and ask them, how do you measure weight? What unit do we use to measure weight? Again, what is the question? The question is, the apple falls, the apple hits the ground brings it to rest. When it is at rest, what is the weight of the apple? Okay, the correct answer is it's still 1 Newton. If I say a 1 Newton apple, I'm talking about the weight of the apple. The planet doesn't care where you are. If you're on the ground, if you're on the tree, if you're falling, you're still having the same m times g. Your mass isn't changing, the field isn't changing. Unless the tree is Yggdrasil and it's falling from outer space. Anyway. I did. And what was the answer? No, that's not what I said. What is the weight of a 1 Newton apple sitting on a tree? 1 Newton.
Okay, F net will be.
Yes, if it's just sitting there, F net is 0, not weight. Okay, so if the apple has fallen and come to rest on the ground, there is no net force on the apple, by the way. The F net is 0, but that doesn't mean the planet stops pulling on it. If it has a mass and it's near a planet, mg, baby. The correct answer is 1 Newton. Again, I want to emphasize that weight is a force. We measure forces in newtons. So if you tell me that the weight of the apple is 1 kilogram, you're doing it wrong. Write this down. Big notes on your paper. No, screw that. Go get a tattoo on your forehead. Backwards, so you read it in the mirror when you brush your hair. Weight is a force, is measured in newtons. Okay. I've asked what's the net force when it's not moving. You use the idea that if it's not moving, it stays not moving. Net force has to be balanced. I asked for the weight when it's not moving. Weight doesn't matter if it's moving or not, negative mg. Half a second. I asked for the accelerate. Did I ask for the acceleration as it's freely falling? I didn't, did I? No, I asked that verbally, and I heard a big chorus. I think that's all I can juice this apple for. You had a question, though. Sure. Great. Follow-up. Yes. If someone tosses the apple, what? Let's do it. If somebody tosses the apple, then here's an apple. Here's an apple, but I'm not tossing him. Hey, here's an apple. I toss it up. What do you want to know? What do you want to discover?
How long it takes to get back.
That's kinematics. I would use change in velocity is change in velocity is AT. Okay, great. I throw an apple up. I throw an apple up with initial velocity 5 meters per second. Initial velocity is 5 meters per second. Google form O, how long does it take to reach its peak? We're moving on to kinematics now. I throw an apple up. How long does it take to reach its peak? The answer is not in newtons. I'm asking time here. I'm giving it an initial velocity 5 meters per second. How long does it take to slow down to 0 meters per second? Oh, that's maybe, oh, spoiler. There is enough information, I promise. Use the equations that you've learned. Use your note sheet. I'm asking for a time, by the way. Don't tell me meters per second squared and don't tell me newtons. If I ask a how long question, I'm talking about time. How long does it take before it reaches its peak? Again, I throw an object upward with initial velocity 5 meters per second-ish. How long does it take to reach its peak? And because there are additional questions here, if you asked, we get one sheet of notes for the test. The correct answer is half a page front and back. You could also do one page, just the front. Okay, I've given a hint on the board for an equation that might be useful to you. I encourage you, even if you're done, to see if you can apply this equation to the problem and check your answer. There are a bunch of correct answers, but there's still a bunch of wrong answers. No, you don't need the displacement, by the way. Ask yourself this, riddle me this, Batman. What do you know? What is given if I say I give an apple initial velocity of blah, it reaches its peak. How long does it take to reach its peak? And the hint is you can do this all in one step with this equation. You should also apply a sanity check. You can rule out wrong answers if you think about how long a second lasts. 5 meters per second, even I could throw it 5 meters per second, and 49 seconds, or nearly a minute in the air, should seem fishy. You can't jump to the correct answer, but you can rule out wrong answers. Okay, and here's how to do this. What is the acceleration of a thrown object? Always and forever, you don't need anything else. Negative. Okay. If I throw an object upward with initial velocity 5, final velocity 0, it reaches its apex. What's my change? What's my final V? Okay. Google question P, what is my final velocity? I throw an object up with initial velocity 5 meters per second. At its apex, The velocity is, apex means highest point, by the way. One more time, the follow-up question here to guide you to the answer is, what is the velocity of a freely falling object at the apex of its motion, the highest point of its motion?
So I don't touch it, but.
Okay, here's how to reason about this. We got a lot of correct answers, but you need to know this or you're going to die, okay? Suppose the answer is positive 5 meters per second. The next instant, where am I? Am I not higher than I was? Right? If you've got a positive velocity, do I not go higher the next moment? So if you're at the highest point, is your velocity positive 5? Your velocity can't be positive anything. What about negative? If your velocity is negative, if your motion is moving downward, you're moving at negative 5 meters per second, weren't you higher a moment ago? Your velocity at your highest point cannot be plus, cannot be minus. When your position is at its maximum, your velocity is 0. Remember that. If I tell you I drop an object, I release an object from rest, the object is its highest point of motion, an object is turning around, all of these are hints for velocity at that instant is 0. So the correct answer is my final velocity is 0. If I am talking about reaching the highest point. What's the initial velocity? 5, because I told you. How can I solve this for delta t? What's delta t? Google form, Q, solve this for t. Here, make the mental math easier, round 9.8, okay? Solve this for t. Watch your algebra. This is Q. Let's check your algebra. Negative 10 equals negative 5 over what? By the way, I'm looking for time. Please don't tell me Please don't tell me meters. Please don't tell me meters per second. Okay, so here's how to solve this equation. First, I have a negative on both sides. Pew, pew. I multiply both sides by -1. Next, I've got a delta t that I want to simplify towards. I don't like fractions. Let's get rid of fractions. I can get delta t out of the fraction by multiplying both sides by delta t. How is the 10 attached? The remaining factor that I don't want is attached with multiplication, so I divide by it. Correct answer is about 1/2 a second. Question me. Multiply what by 5? I didn't multiply by 5, I multiplied by t. What's the other way? If I divide, both sides by 5, I get a fraction 1 divided by x. If I multiply by 5, the right-hand side becomes 25 divided by x. Check yourself here. If you get 50, go back and plug in the numbers and see if that works. What is 5 over 50? Is 5, if I have 5 pies and I split them into 50 little chunks, how big is each chunk? It's not 10. 5 over 50 is a tenth. Sanity check the other big wrong answer that I saw commonly. 2 seconds. If time is 2 seconds, if I take 5 and split it into 2 pieces, how big is each piece? 2.5, not 10. So sanity check. Check yourself before you wreck yourself by plugging back in and seeing. Yeah, question. Great. No, we're not done yet, but I've got to guide people through where their struggles are. Okay, so the final step, it's the final step now. It's the final countdown. I ask you if it takes half a second to get to its peak, how long does it take to get back to my hand? Try it in the Google form. Question, what are we on? Oh my God. Or we have discovered it takes half a second to get to its highest point. What is the total time it takes to go up and down? Let me give a follow-up for y to multiply by x. My wife has a PhD in teaching math. She has done 7 years of research on how to explain better. I'm a physics teacher. Email me. Let me put you on the line with her for 5 seconds and she'll explain it way better than I am. By the way, that goes for all y'all. If you guys have a math question that's just not, what I'm saying is not clicking, email me. I'll set up a time with her, God willing, and she should be able to explain most math struggles way faster and better than I am. That's not my subject of expertise. The math end of things. Okay, so good. If it takes half a second to go up, by symmetry, it'll take half a second to go down. The correct answer is 1 second. Half a second to go up, half a second to go down by symmetry, 1 second total. Okay, did that answer the question about the apple? Is that what you asked, by the way? Yeah, the time to go up and down? Yeah. Okay, how fast is it going when it hits your hand again? T, question T, how fast is it going? Use the equations or use the concepts. No, this is S, sorry, S, find the final speed. The speed when it reaches your hand. Velocity, give me the velocity, let's say. Velocity. The instant before it strikes your hand, what is the velocity of the apple? I throw an apple up with 5 meters per second upward velocity. We have discovered that it takes half a second to reach its peak. I'll just tell you, it takes half a second to get back down. How What is the velocity once it reaches my hand again? The instant before I touch it. There is.
Yeah, right here.
Once I catch it, catching is a different process. I don't know how hard my hand is reacting. I'm not talking about after my hand has pushed it to rest. How fast is the motion the instant before it touches my hand?
No, I'm just. And literally-
We're running low on time. I've got a couple of more procedural questions about the final exam. So let's talk real briefly the fast way to do this. Same equation. Instead of just talking about up, let me talk about up and down. Time to go up and down is 1 second. Acceleration is still -10. If I have the equation -10 equals v final plus 5, minus 5, I could solve this by adding 5 to both sides. I've got a subtraction, so I solve it with an addition. -10 plus 5 also goes by the name -5. The final speed is -5 meters per second. This is the defining equation for acceleration. Okay, Google question T. Google question T is, ask me a question about the final, because I got several along the way. Final, midterm. I got several questions along the way that I didn't get a chance to answer because I was focusing on something else. If you have a question about the midterm, any question whatsoever, except for what are all the answers, any question about the final? Midterm, for God's sake, midterm. How many calculation questions will there be? About a third of them are calculation questions. Roughly. Third to a half. What? Going to be a material. What? What's a material question?
Like, or it can have, like, or I don't know, like.
So they're all multiple choice. They're all multiple choice. Yeah, how do you, it's a Scantron, right? Okay. Shh. All the formulas are going to be from the homeworks and quizzes. Yes, if we haven't practiced it multiple ways, it's not going to be on there. How many word problems are there going to be? 20. How many problems are there going to be? 20. Do we have to take it? No. I'm just kidding about the midterm. Psych. Yes, in fact, you do. The exam is in here, right? Yes. Bookstore woman said to double check with professor what Scantron. It is a maroon half sheet, a pink half sheet. Will there be graphs to analyze, either verbally or visually? Yes. If we finish early, may we leave early? Yes. What are some formulas you should have on your paper? Figure it out. Is it a pink or a red Scantron? Yes, same diff. What happens if you forget your Scantron? 30 lashes with a cat of nine tails. How many questions of force are on? About a quarter. If you have any further questions, come on up here.